Good Thursday morning. How you doing out there? I want to make a video about basic tube testing. I've done this before, and it's very difficult for me to get the camera. There's going to be a lot of camera shaking and so forth in the video, but I'm doing the best I can. I cannot get a good camera angle, but I'll try my best. I'm going to use two tube testers, a cheap mercury tube tester, and my B&K 606 tube tester. Going to test a couple of tubes. I want to touch base on a very, very important thing that you must do when you are testing tubes. And that is always start out with your filament switch on your tube tester set at the lowest setting. That's number one. Number two, before you even get involved with vacuum tubes, get yourself at least one tube manual. I prefer several. I have several. I have maybe, I don't know, 1, 2, 3, 4. I have at least 5. The oldest being 1946, I believe. The reason you have several different tube manuals is because on the newer one, they don't list like your 75s, your 45s, and your 27s, and tubes like that. And they may list them, and they'll just tell you what they are, and the details are not always there, like your pinouts and so forth. So you want to have an old tube manual to cover those tubes. But most of you out there won't be working with that stuff. There are some that do. So the tube testers I have will test those. My Radio City Products Model 308 tube tester, which I got on eBay years ago, will test the real old tubes. But primarily, I use mostly my B&K 606, but regardless of what tube tester you are using, make very sure that you set that filament switch to the minimum before you even put the tube in. And once again, I'm going to be repeating myself in the video, I'm sure, that the first number on a tube is always the filament voltage. So if it's a 12AX7, that is a 12 volt filament, or 12.6 to be precise, volt filament. 6X5 will be a 6.3 volt filament, because that first number is always your filament voltage. I grew up with vacuum tubes, as you will know, and I'm very, very weak with transistors. I know a little bit, just enough to get myself into trouble. My problem is my eyesight, as you all well know, and when it's real small stuff I can't work. I even have a difficult time with vacuum tube stuff working on certain chassis, mainly because I just can't see what I'm doing. But we're not getting into that again. I just want to do that because mainly to help Jack, Vintage Electronic Geek, I believe. I want to help him out. I occasionally watch his videos, but I'm so busy doing stuff on my own and watching other videos that I don't really get a chance. But he's one of my viewers, and he's chimed in before on my videos. So kind of like, this is not only for Jack, but anybody that kind of would like to know the basic ins and outs of using a tube tester. And there are many videos on YouTube as to how to use a tube tester properly and so forth. So I'm not a very good teacher. I can't see good, so I try to demonstrate something, but I usually get my ugly head and my hands in the way because I got to get my magnifier right up there on the tube switches and so forth. So I do my best, and I hope I can be of some help to you newbies out there, and also you oldies out there that may be into transistors and don't have a lot of experience with vacuum tubes. And I am no expert on vacuum tubes, but I did grow up using vacuum tubes. I love working with vacuum tubes. I love looking at the filaments lighting up. I love the smell of old electronics. And vacuum tubes are the best. That's the way it is. Yes, some of my test equipment here is solid state, of course, you know. And when it comes to repairing them, no, I can't repair them. But anyways, let's get on with the video here, and I'm going to try to keep it short. That's easier said than done. It'll probably take me all day to render this, because it is going to be done on my JVC, which I'm using now, HD camcorder, because I can get real close. So let's get started. Are you ready? Let's go. Here is just two of the tube manuals I have. I have 1, 2, 3, 4, 5 other tube manuals. I've gotten these from eBay. Not recently. I think it was 2019, I think was the last time I got one here. And this is a 1946 tube manual. And the reason you want to get different years of tube manuals is because the newer ones don't cover the real old tubes, or they give you the real old tubes, but not a lot of detail on them. And if you want a lot of detail, then on the real old tubes, then what you want to do is to get the real old manuals, and they'll give you more detail on the old tubes, like let's say a 75 tube now, which is, you know, in the 30s, in the 1930s. So if you were looking for a 75 tube, you'd be looking, and these are what they call the shoulder type of tubes, these heat type here that look like that. Well, we're in the 43 now, and in the 46. Matter of fact, this book may not even show that. May it go back? I think this is the oldest book I have. Yeah. Okay. But what the point I'm trying to get across is, all right, now you got your charts and things like that. I don't really follow that. I'm not that knowledgeable. I'll tell you right now, I'll be honest with you right up front. The most important things that you want to know about a tube is the physical specifications, typical operation, and it gives you the maximum voltage. And I got to get a magnifying glass because I can't see even with the viewfinder, and I have reading glasses on. First of all, you got your pinouts here. This happens to be a 6SK7. 6SK7, the GT stands for glass tube, okay? That would be this one right here, and this would be the metal version. A metal version it contains a glass envelope, which is vacuum sealed, just like the glass tube, inside the metal shell. The metal shell on any metal tube, pin number 1 is always ground. It's grounded to the chassis by way of the tube socket. So anytime you got a metal tube in a radio, the metal tube is the ground. In other words, that tube does not need a shield. There are some radios that'll have a shield on the tube. Sometimes you can replace the glass tube with a metal tube of the same number. Most of the time, unless pin 1 is not grounded, it could be a tie point for something else, in which case you can't do that. However, your ratings gives you the first number on a tube is the filament voltage. In this case, it's a 6-volt tube. The actual voltage is 6.3 volts, alternating current, of course. If it's a 12SK7, it would be a 12-volt tube, and it would be identical to the electrical internal elements, except that it contains a 12-volt filament versus a 6-volt filament. But always, always get yourself a tube manual. That is very, very important. I cannot emphasize that enough. I believe you blew the 6X5 on your signal tracer, Jack, and 6.3 volts is what you have to make sure. When you look at a tube number, the first number is always the filament voltage. In this case, it's 6 volts or 6.3 volts. If your tube tester does not have voltage markings and just letters like yours does, always keep, when you start your tube tester out or before you put it away, make sure that filament switch is all the way down as low as it can go. In other words, set it down low, because that is exactly what happened. You had your filament voltage up to at least 12 volts or maybe even 25 volts. Each letter is an increase in voltage as you go clockwise on the dial of your tube tester. I have tube testers that have numbers like that, letters rather, instead of numbers, filament voltage. So it's a good practice to keep your numbers, your tube tester dial all the way to the left, always. And of course, your tube tester turned off like you did. Put the tube in, make sure it's in the proper socket. Check your chart and set that first and make sure your filament voltage is correct. So you have a tube manual that will tell you what each element ratings are, where the plate is, where the grid is. It's a 6X5 is a twin diode, indirectly heated cathode. In other words, it's not like a 5U4. A 5U4 would be a 5-volt filament, would be a directly heated cathode, which means directly heated filament, which also doubles as your cathode. Okay, in this case, a 6X5 has an indirectly heated cathode, which means the cathode is separate from the filament. Your cathode is where you get your positive B+ voltage out of, and your heater, which is your filament, is inside the cathode sleeve, and it has a potential of anywhere from 200 to 450 volts, depending on what your power transformer is putting out. So let's get another tube manual. All right, here is your 6X5. I'm on the RCA tube manual now. It's a lot easier to read, and the tube location, which pin locations are right here. Fingers were invented before pointers. Now, if you look here, And you have to excuse me because I am using a magnifying glass on the viewfinder of the camera. Pin number 8 is a cathode. That is your DC output. Okay, pin number 3 and... Okay, pin number 3 and 5 on the top, okay, is your plate. That is where your secondary of your high voltage transformer connects to. It's a full wave rectifier, okay. Indirectly heated cathode, which means the cathode's completely electrically separated from the filament. Your filament is, excuse me again, I cannot read that. My eyes are piss poor. 2 and 7, okay? I used to know this by heart. I've been away from tubes for a little bit here. Not that long, but my mind is like a sieve, so you have to excuse me. So I'm not a very good teacher, but maybe I can show some people that are not familiar with this stuff at all and be helpful in my own small way. Pins 2 and 7 out of filament. So what you did is you blew the filament out. It's rated at 6.3 volts, and you applied a lot more than that on there. Pin number 1 is not used, okay? And it's a very simple tube. It's a dual diode rectifier, full wave rectifier. Your 6X5 is usually the older version. 6X5 GT is a glass tube. That's what it stands for. Okay, so that is the difference between an indirectly heated cathode, which is what this is, and a directly heated cathode, which I'm going to go into next. A 5U4, like I say, you may not ever run into 5U4, but this is for anybody that's working on this thing. The filament voltage is 5 volts, 3 amps, so it draws 3 amps off the filament winding of your power transformer. So it's a pretty substantial current draw on a transformer. But anyways, let's get back to testing tubes. What you want to do, and this goes for any tube, you know, that you are going to be testing. The first thing you want to do when you look up a tube, okay, and you're going to test it, get yourself a tube manual. Make sure you have a tube manual. Look up what the filament voltage is. Yes, you can look here and say, well, this is a 6K6, which is a power pentode audio output tube generally used for that purpose. And it's a 6.3 volt filament. And so just make sure, and if you're not sure where your filament pins are, you look in the tube manual, it'll tell you right there, in which case it's usually 2 and 7, and that's what it is. It's 2 and 7 in this case. Where am I? Here it is. Okay, and that's on a 6K6, okay? And it'll tell you in the book what the filament voltage is. Again, I'm at a disadvantage. All that is blurred to my bad eyes. It's in focus on the camera, but it's too small. I cannot read it. I can only read it after I play back the video. So what I'm going to do is I'm going to get my tube tester out, and I'll show you. Okay, this is my cheapest tube tester. This is similar to what you've got. And by the way, Jack, I had a tube tester similar to the one you had, only it's a Lafayette, so it's basically the same, you know. And this is the same thing, too. I got this at Jewett City a few years back. I believe it was Jewett City. First of all, this here is not a high voltage lead. There is no high voltage in these testers. they work with very, very low voltage. And what an emission tester does basically is ties all the elements together, your grid, your suppressors and everything, and to the plate. And it leaves, it literally uses all the elements with the exception of the cathode and the filament, and gets the emission reading directly on here. So these are okay for testing for shorts and so forth, and generally telling you if the tube is good or bad. The best tester is a mutual conductance tester. I do not own one. I used to. Kick myself for getting rid of my Hickok 6000A. I'll never be able to get another one again. So I've got this. I've got the Knight 600, and I've got the Radio City Products Model 308, I believe it is. Okay, so here on this, I got the tube setup chart for this. So what we're going to do here is we're going to test a tube on it. Now, if you notice, right over here, this is your filament, okay? It's not marked filament, but it is. And again, in my case, I just got numbers. So I don't know where my voltage is, okay? So what you want to always do is keep, before you do anything, before you put a tube in here, before you turn it on, make sure this is down all the way. Whatever the lowest reading would be, usually 1.5 volts or thereabouts. Every tube tester is different. On this particular one, if you were to mistakenly jump it over to here, you're at the highest voltage. You know, most of them don't do that. So it's very important. The filament is the most important thing to set on your tube tester. That is what will ruin your tube and blow it out. Always keep this down. I've mentioned this before in other videos. So what we're going to do now, I'm sorry for the shakiness, I'm trying to hand hold this. I have here a 6J5, which I've already tested quite a while ago. J5. Okay, now before we put the tube in, we set our settings. Let me, let's see, okay, I'm just trying to make sure that you can see everything. Of course, I'm on an angle, I always am, and I have to be a contortionist, as I just can't get my camera set up like most of you guys can do. I notice a lot of you fellas do a good job putting your stuff on video. I just can't seem to get in camera properly without having to twist sideways in order to show you. 6, what did I say, 6J5? Mine's like a sieve. Yep, mine is like a sieve. That's why I'll never be a teacher. All right, it's telling me to set X, which is this one, to number 8. You notice that there is no filament voltage on that. So number 8, I'm on number 7. Sorry, I have to get my ugly face in the way. All right, so number 8 should be 6.3 volts. This is a 6-volt tube. 6.3 to be exact. All right, so the filament is set. Okay, notice the tube is not in. All right, the next setting is E. Y should be set to E. All right, that also turns the tube tester on. A, B, C, D, E. Okay. All right. All right. Z is 5. Can't see that. All right, that's 12. That's why you don't plug the tube in, because it jumps all over. It goes to a high number to a low number very easily. Say, in other words, this control goes completely around, just like the filament. So it's vital that you do not plug the tube in until you got all your settings right. So what did I say? Mine is gone again. Z is 5. All right. 2, 3, 4, 5. Yeah, okay. 5. W is A. And that would be... I'm using this tester because this is similar to what you got. A, all the way up. Okay. You see that right there? I don't know if you can see that. Yeah. Okay. All right. Now, and socket number 4. That would be right here. At this point in time, we are safe to plug the tube in. And normally, I don't use this tester. I mean, this is the second time I used it. Because I rather have a tube tester that'll have the filament voltages right on here. But, okay, the tube is in. Tube is lighting. Now, I don't remember how to test for shorts. I'd have to study the front of the book. So we're not going to do that. Normally, you'd rotate one of these switches around. In your case, you've got slider switches at the bottom, but it's basically the same thing. Whether you got a row of slider switches here or whether you got controls here, they do the same thing basically. So press for quality. All right. You see how this has one of these cheap meter movements. See how it jumps around? It's an inexpensive deoscible movement with no dampening in it. But it don't matter because the tube is good. But it's very important. I can't emphasize this enough. Always start with your lowest filament voltage. One of the worst things that somebody could do is to test a high voltage tube like a 35Z5, for instance. That's a 35 volt filament, or a 50L6, which is a 50 volt filament, which would bring your switches way up into this range here. And then the very next time, testing a 6 volt tube and forgetting to turn this down. Always bring this down before you do anything else. So you're done for the day. Turn your tube tester off, which is in this case this switch. Then bring your switch all the way down. In my case, it's down to 1. Okay? Always leave it in this position. Get all your switches set. Double check your filament voltage. And put your filament on the proper voltage. Whether it be letters or numbers like I have, or the actual filament voltage. Okay, I have my better tube tester here, my B&K 606, and no tube in it. Always make sure that the filament is down low. This is the filament. In this case, the filaments are marked in rough voltage ranges. Okay? Again, handheld, so I apologize. Like 4 to 5 volts, 6, 7 to 8, and so on and so on. Okay? But again, you see this? You're at the 1 volt here, right? It's very easy to get the 35 to 50 volts over here. I'm off camera again, always, nothing new. Alright, so you're very, very important. You always start out at the bottom. Okay, now, off camera I set all my settings. The load, which is A on 42, B on 1, and C on 5. Okay, and again, we are testing a 6J5, I believe. Unbelievable, my mind. 6J5, yeah. I'll tell you, I just can't retain memory. Honest to God. Okay. 6J5 is the settings up here. So we're all set to go. We got to go into socket 3, which is right here. All right, we're still down here on the filament. Still off camera. Okay, so we're going to put it up to 6 right now. Give the tube a chance to warm up. It's lit. Always give the tube about at least 30 seconds. Good policy to check for shorts first. In this case, on this tube tester, you rotate this for shorts, okay? And the short indicator is up here. So we already, these, I think this was, yeah, this was tested. Okay, so we're going to check for shorts now, and I gotta shade this so that I can see this. And we go all the way around. It don't matter whether you go clockwise or counterclockwise. A momentary flash is okay. Okay, no shorts. And this tube tester has grid emission, which is here. No grid emission. If there was, you'd be reading on the bottom scale. And if the needle moved out of the green and the extreme left on the bottom scale, that would be the grid emission scale, and the tube would be bad. The emission is good. Okay? Again, this is an emission tester, but much better than the other one I got. But essentially, they tie all the elements together. And so really, it's better than no tube tester at all. It'll show about 95% of tube problems. And although I used to, when I had my Hickok 6000A, I'd use that all the time. That was my primary tube tester years ago. All right, now we're going to go test a different tube here. Here's a 6K7. You're probably wondering why I got this wire tie on here. The metal base on this tube actually separated from itself. Tube is good, been tested. It's a 6K7, has a grid cap on it. So we're going to look that up, and I'll be right back because I'm going to have to get my head right in here in order to look up the 6K7. Okay, we're set up on the chart up here. There's my chart up there, but I have to get my ugly head right in the way of the camera. So I've already preset the dials. And the filament is down to 1 right now. Even though it's another 6.3 volt tube, we still put it down to 1. It's just a good habit to get into. Keep your filaments down as low as you can get before inserting any tube in the socket. Again, we are on, I'm sorry, I got to get my head up there. I forgot what tube socket it goes into. 6K7, socket 3. Okay, that's what I thought. Mine is like a sieve. Don't get old. Okay, now, you can't test this tube with the grid cap on. Okay? There's 2 different sizes on this particular one. Okay? That's too loose. You got to turn it around this way and push it on. Okay? That's your grid cap. Now, if you were testing something like a BQ6, which is a horizontal output tube for a television, the cap would be a plate cap. Again, there's no high voltage involved in this. This is just part of your emission test. It needs to be connected because if it's not, most tubes will not read on the meter. So this has to be on. No grid emission, and we have a good tube. Okay, now, let me get you back a little bit. Well, I'm going to have to do it this way. I got to get my magnifier. I want to try something to see. All right, you can see the needle going. See the needle going? I'm holding the button down. All right, let's take the cap off. I'll show you. I'm going to take this cap off here. All right? That's an essential part of your emission test. It must be on there. Okay? If the tube has a cap, a grid cap, which is, this is a grid cap. It's not a plate cap. Not on this tube. That's why you refer to your tube manual. This is not a power horizontal output tube. It's way too small. Wrong number, wrong type of tube. But this doubles as a grid cap or a plate cap, depending on the tube. Okay, so that tube is good. So I can't emphasize enough on anybody that has a tube tester. Put this down to the lowest number at all times. And then put your tube tester away. Next time, because the next time you test a tube and you leave this on 6.3, let's say, or whatever you got, and you want to test a battery-operated radio that has a 1L6 in it, or 1U5, that tube is going to light up like a flash bulb, very briefly. And that's the end of your tube. Once the tube filament goes, that's it. So that's about all I can really tell you. I'm using HD, so it's probably going to take me several hours to render this. And I'll try to edit it down a little bit. But this is for anybody who is not familiar with tubes. Again, I'm going to just say, very, very important, if you're going to deal with vacuum tubes, you've got to have at least one tube manual in your workshop. Always.